Okay, so before the break, we saw how we can take the input from the user and display it to the user. Then we looked in the concept of structured programming, so we can create a structure in the program using the if statement or the loop. Okay, we did not discuss the loop, but we have done it earlier in VBA. So the loop which we saw earlier was if and end, right? We did not give any else. So if the statement is true, the program will do something. If it is not true, the program will not do anything. But we can use it with else statement as well. So the program will check the condition. If the condition is true, program will do A. If the condition is not true, the program will do B. Okay, so there are two things to be done. One for the condition is true, the other one if the condition is false. So let's say we want to develop an M file, a script file, okay, which will check if the grade is over 60. If it is over 60 or if it is 60 or more, it will print pass, otherwise it will print fail. Okay, so let us start. So first of all, we can ask the user to input the grade. Okay, so let's say the grade is input, enter the grade. Okay, then the next thing will be to put the if condition. Okay, so you can see now the if statement has two functions or two tasks. One if the condition is true, the other one if the condition is not true. If I have to check three conditions, okay, but two of them must be true, then what should I do? If I have to check total three conditions, the first case is two of them it's true, and the second case is the third one is true. What should I do in that case? And okay, I will with the first two in the if statement I will use the and. Okay, and in the same line you can use the not as well if you want, or the or as well if you want. So not and or and all of them can go with the if statement in the same line. Like we saw in the previous example, there were I think 4 conditions, right? So they can go with the if statement. Okay, and within the if you can create a nested if as well by using else if. So with the if you can use, if the first condition is true, it will do some action. If the first condition is not true, it will check another condition. Okay, so else if you are using only else, it will just check the first condition, true or false. If it is true, do the first action. If it is not true, do the else action. But with else if, I am saying if the first condition is true, do the first action. If it is not true, check the second condition. Clear? And then you can then check the condition and so on, and then you have to end. Okay, every if statement must have an end. Okay, and so we need M file to display A if the grade is over 90, B if the grade is between 80 and 90, C if the grade is between 70 and 80, and F if the grade is less than 70. So imagine you are in medical college now, is what they do there. Our health sciences college, my colleague is there, he was telling me their passing grade is 70. Okay, you want to transfer, you can do this. Okay, very simple, very clear. The only thing is with each else there was a new condition, except the last one, where if you don't fulfill any of these conditions, then obviously it's an F. Okay, we have a sign function in MATLAB. MATLAB has a sign function, SIGN. It's already there. And what is the purpose of this function? This function returns the value of either -1 or 0 or 1, depending upon what the number is. If the number is less than 0, then the function will return -1. If that number is negative, the output of the function will be -1. If the number is 0, the output of the function is 0. And if the number is positive, more than 0, if the number is more than 0, then the function will give us the output +1. Okay, so there is a function in MATLAB. Okay, the syntax of the function is SIGN, and whatever number you put in the bracket, if it is less than 0, the value of the function will be -1. If it is 0, the value of the function is 0. If it is more than 0, the value of the function is 1. Okay, it's already there. But let's say this function was not there, and somebody asks you to make this function now. So you have to create a function which can do this. Okay, clear? So it's very similar to this, and you can see the examples over here. So first of all, we'll open a function file now. Open a function file. Okay, open a new function file, go to new and function file. Okay, so everybody created the function, right? Okay, and it's working. They did it in steps. You can have a look at it later on, no problem. Okay, and they did it like you as well. Display the value, positive, negative. Okay, here you can see they are just checking the value and displaying if it is -1 or positive, negative, or 0. There is no output of the function. See here, the function you created has an output. What are the three outputs? -1, +1, or 0. Is there any output here? No output. Got it? So it's just a display function. Okay, this is the last one we created, huh? Okay. Okay, so this is like a summary of if you are using if statement only without any else, then you are just checking one condition and that's it. If the condition is true, program works. Condition is not true, program doesn't do anything. Then if you use it with else, condition is true, program will do something. Condition is not true, program will do else thing. And the third one is condition is true, program will do something. Condition is not true, program will check something else. Okay, and what we have seen with you, that else if must be without any space. If you put any space, then this starts a new if statement. Okay, and the new if statement will have its end and so on and so forth. Okay, so else if you don't need any extra end. Okay, so you can see in the third case we have if and else and only one end. If you do else and space if, you have to put two ends, one for this one for the last one. Okay, then we know about the loops, right? loops will perform the calculations repetitively. Okay, and we have two types of loops, for loop and while loop, the same which we have used in VBA as well. Okay, so we have the first one, which is the for loop. So it will run as a for end structure. It has a for end structure. So you will give the for, the function or the command for, then you will give the index meaning the variable to which the loop will run. Okay, and then you will give after equal to the starting of the loop, the interval for each loop, and the ending of the loop. Okay, and you will perform any statements which you want within the loop, and then you will end it. So the main thing is it should have a for, it should have an end, and for should have an index, an equals to sign, and a start and end and an increment. Okay, if you don't give the step, a step means increment. So how will it go from start to finish? So if you give a step of 2, it will increase the number every time by 2. Okay, if you don't give anything, what happens? We did it in VBA as well. If you don't give any step function, just the start and finish, then the increment is how much? If you don't put the increment, if you don't mention the step, the default value of the step is how much? 1. Okay, so it will go from start to finish 1 by 1. Okay, so you can see the statement over here. That's example. What is my index? I. So I is changing every time. It starts from 1, goes to 9, and every time it will increase by 2. And what is the loop doing? They're displaying the value of I. So first of all, it will display 1. Next time it will display how much? 3. Next time 5. How many times the loop will run? Count. How many times the loop will run? Huh? 5 times, right? 1, 3, 5, 7, 9. Okay. Now if I put a display statement here, same statement, after the loop, what will be displayed? 11. Because when the loop ended, I was 11. That's why the loop ended. Up till 9, the loop was running, right? So when the loop ended, the I was 11. After 9 plus 2 again, right? Clear? Again, something which we discussed in VBA as well. Same thing. Got it? Without that step, so 1, 2, 3, 4, 5. And again, if I put a display function after the end, what value will be printed? If I say display I after the loop, 6. Okay, so you can use a positive step or negative step. You can use a step in fraction as well, 0.5, 0.2, any value. If you are using a negative step, then the start and end should be descending order. Start should be higher, end should be lower. Like this. So the step is -1, the start is 10, end is 1. You have to take care of it. Okay. Let us develop an M file which will compute the factorial. Okay. And MATLAB also has a built-in function for factorial. MATLAB has a built-in function for factorial, but we will develop our own function for factorial. Okay. So now open a new function file. Okay, the same thing which we did. Okay, so these are some examples of doing the for loop. Okay, here you can see loop is assigned to a matrix. there's a matrix A and I is assigned to the matrix. We did not give any starting value, any end value, any step. What will it do? The first value is I has the first value of I is how much? The first value of A. Second value of I is how much? Second value of A. Okay. So this example will display what? First of all, it will display 5, then 8, then 3, then 4, then 12. Okay. You can do this like you can do it like this. Okay. Second example for a reverse loop. Okay, so it goes from 5 to minus 2. So which value will it display? First value. What is the first value? First value is how much? What is the first value? 5. Okay, next value 5 minus 2, which is 3. Then 3 minus 2, which is 1. Then 1 minus 2, minus 1. Okay, and then will it display minus 3? No, loop will end. Okay, up to minus 1, then the loop will end. So let's say we want to use a for loop for summation of even numbers between 2 and 50. We want to have a loop for summing up the even numbers between 2 and 50. Okay, so let us see how we can do this. The thing which we did. What is different here? They created a matrix. So I is the value in the matrix, and the matrix is, now if you pay attention, this format is same as this one, right? Okay. How we assign the values and how we do it, the loop is the same. Okay, so if you remember this one from the first example, you know how to use the second example. Okay, so I is the first number in the matrix, and the second number in the matrix, the third number in the matrix, and so on. And how do we assign the matrix? Same as we assign the loop. Clear? Okay, and inside the loop is the same. What's the difference here? We are running the loop from 1 to length of I. Length of I means what? Or length of A, sorry. Length of A means what? The loop will run how many times? The loop will run how many times? The length function is doing what? The number of members in the vector A. So if A has 25 numbers, the loop will run 25 times. Clear? Okay. And each time it will take that number from the matrix. Okay. So you can see they are making it complicated, but they are trying to show you different things. This one is the simplest one which we did. The first option is the simplest one. The second option, they are showing you how to assign values to a matrix and how to use them in the loop. Third one, they are showing you how to use the length of the matrix and how to call a member from the matrix. So AI will do what? Take the first member, then the second member, the third member. Okay. Okay. We saw this earlier, but now you can see the use of it. So I don't want to use all the values, I want to use each value from A. You can do it like this. Use simple bracket, and then within the bracket the order, the number of the member. Clear? Any questions? Okay. So we want to write a for loop which will generate an identity matrix of 6 by 6. Now you can see the identity matrix is on the board, it's in the slide. So what is an identity matrix which has what? Diagonal is 1 and the other members are 0. Okay. Now for creating for creating a matrix which has all zeros, we have a function. The function is zeros. The name of the function is zeros. Okay. And then we can create a matrix of zeros. Then we can change the diagonal values to 1. Okay. When you are using the zeros command, it always creates a square matrix, so we don't need to use the rows and the columns. Okay, clear? And then you can see the display command. Display will display all the elements like this. Clear? Any questions? Okay. Using a for loop, find the summation of all numbers in a vector A. Output the result in a command window. Okay. So there will be a vector A. Okay. And then you will do the summation of that vector, and then it should show the result in the command window. Okay. We already seen it. So first thing is have a value of A. Okay. And then you do the initiation, some 0, and then the loop will run from 1 to the length of A. If A has 5 elements, it will run 5 times. If A has 6 elements, it will run 6 times, and so on. Okay. And then inside the loop, it will take each element of A and sum it. Okay. What is the other option? Can someone tell me the other option? How can I change the loop here? So this is option 1. Okay. How can I change the loop here? Instead of doing it from 1 to length of A, I can do what? Huh? 1 to 7. Okay, we can do it. We can do 1 to 7, no problem. So loop will run 7 times because A has 7 elements, right? Okay. What else? The loop can be for I equals. She's saying we can make I equals 1 to 7. Yes. Or we can make I equals A. I equals A. Okay. Then within the loop, sum equals sum plus I. Got it? Because I is taking the values from A, right? Clear? So whatever is A, 7 elements, 70 elements, 7,000 elements, doesn't matter. I will keep on running until you finish A. You don't have to assign the values. Got it? Clear? Any questions? And so in the previous example, the A was fixed. Here you can ask the user to give you the value of A. Got it? Okay. Can you try it? Try. You will enter the value of A. You can try it directly in the command window. Okay. Or do it in the editor window, no problem. So the first example which we saw, A was fixed. In this example, you can change any A. Okay. So now we want to find out the summation of numbers in a vector which is more than 60. Summation of values in a vector which is more than 60. You have the program, right? You will make the change in the same program. We'll make the change in the same program. What change? What change we will make? You are doing the summation for all numbers. Now before summation I will put an if statement. Okay, so if I is greater than 60, then sum, otherwise end. Okay, so in the same program, inside the loop, don't do the summation. Before summation put an if statement. If I is more than 60, then sum, otherwise end. Okay, so they are doing the other way around, using the length of a. Okay, so instead of adding I, they are adding a of I. I of a. Okay, because the loop is from 1 to the length of I. So each time it will check each element of a, the ith element of a, and then it will add the ith element if it is more than 60. Got it? So it's slightly different than what you did. Okay, which is good. You can see both versions. Okay, so another loop for counting values which are more than 5. So now it is counting. Counting is also like adding, right? So again we should initiate with, okay, and sum equals to 0. So counting is also like adding. So you enter the vector a, you can make it like this or you can make it what you have. Ask the user to give it to you. Okay, and then the loop will run from n to length of I, and here you can see they are adding one more statement which is length equals to n. So n equals to how much? Eight. These are 8 elements, so n equals to 8. Okay, if somebody put 10 elements, n equals to 10, and the loop will run from 1 to n, whatever the number is. Okay, inside again if a statement like you have. Okay, you are checking more than 60, right? Now you are checking what? More than 5. If it is more than 5, don't add the number, just increase the count by 1. And not adding the numbers, we are just counting them. So count is already 0. If it is more than 5, add it by 1. Not go to the next number. Okay, so end and loop and next number. Clear? Okay. Okay. So we want to have a loop which will calculate the value of w using the value of x as 1.2. So value of x is 1.2, then you want to create a loop which will calculate the value of w. Okay, so in these examples you have to look at the equation and see what is happening from one term to the other term. Okay, so you can see the first term is how much? 20, right? It's a constant. Will it change? No. So if it doesn't change, it should be outside the loop. Where? It should be outside the loop. Okay, inside the loop the first term is 3 by 2 x square, right? 3 by 2 x square. Okay, second term 6 by 4 x square. Third term 12 by 6 x square. What is constant in all the terms? In all the terms, what is constant? What is constant? Okay, constant is multiplied by 2. And what else we are doing in every term? X square in all the terms, right? X square is in all the terms, right? Right or wrong? No? It is there, right? X square is there. Okay, so we want to create a loop which has a constant of 20, then every term is increasing by 2, and every term is divided by x square. Okay, and x square is how much? 1.2. Okay, Okay, one thing which you can see here, the same things which we did, but you can see here percentage sign, j equals j is to 2. What is this? What do we call this? Is it a message? It's a comment. Comment for who? It's a comment for us, right? People who did not write the program. Somebody else wrote it, right? I didn't write it. Okay, I wrote this one. Okay, you don't see any comment here. Clear? Okay, so you can put a comment with the equation as well. Somebody opens your file, he knows what you did. Clear? Okay. So another example here. Okay. So x is 2 here, but we are asking the user to input the value of x. Okay. We are again calculating the value of s. In s, we have a constant 5, and then we have the ratios, right? And x is 2, but they are now programming it that x can be anything. So when you run the loop, when you run the program, I can use it for 2, you can use it for 4, same program. Okay. So then you run the loop from 1 to 5. Okay. So 1 to 5 is, we start from here and end here. How many terms? 1, 2, 3, 4, 5. 5 ratios, right? So that's why 1 to 5. Okay. And each time you will calculate. Now this number is what? If the loop is 1, then this number is 2, right? If the loop is running second time, this number is 4. Loop is running third time, this number is 6. So each time this number is multiplied by 2, which is p. So p is the number in the denominator. Okay. And the numerator, x. Now, what multiplied by x? 1. What to the power x? 1. So this is I multiplied by x to the power I. Next time, what is it? Okay. Yeah. So next time, this power is how much? 2, which is the loop. Here it was 1. Next ratio, power is 2. So I, x to the power I. No problem, right? Every time the power is increasing by 1, which is my loop. Okay. So every time x to the power I. Okay. Now what are we multiplying? 1 and 3 and 9. And the next one is 3 into 9, 27, right? And 27 to 3, 81. So every time I'm multiplying I with how much? 3. I multiply with 3, right? Okay. So okay. So first time k was 1. Okay. Next time k will be 3 into 1, which is 3. Next time it will be 3 into 3, which is 9. Next time it will be 9 to 3, which is 27. This one. Clear? Okay. A bit more complicated. Okay. So you have to break it into each term. Okay. So first of all, the first number is constant, so I assign it outside the loop. No, any problem? No problem. X, input from the user. Any problem? No problem. Okay. Then k, a random variable, we initiated it. Okay. To get the values in the numerator, the top values. Okay. So the first value is how much? 1. So k is 1. Okay. Next time it should change with a multiple of 3. So every time the loop runs, k changes by multiple of 3. Okay. Clear? This number, multiple of the loop. The loop is 1. this number is 2. When the loop is 2, this number is 4. So multiple of the loop, 2 into I. Okay, and power is the loop, x to the power I. Clear? Any questions? Okay. Okay, the vector shows student marks. Write a MATLAB program. It finds the number of students which passed the exam, okay, and the number of students who got full marks. Passing grade is 60%. So how many students got 60 or above? It should count them. And how many students got 100? It should count them as well. 2 counts. A statement which is sum, we did not discuss it earlier, now you can see it here. It's a conditional sum. It's a conditional sum. So you can see in the program is now very simple. Okay, sum what? A more than equal to 60. Okay, if A is more than equal to 60, yeah, so sum, and put him in where? In pass. Okay. Second one is full mark, sum, A is 100. Okay, so this is, if you use it like this acts as a if statement and a loop. We use an if statement and a loop here, right? Both of them in a single line. Okay, but if you don't know this will work. Okay, that's why you need, it's not important that how many functions you know. If you know more functions, yeah, your life is easier, but it comes with practice. Okay, but if you don't know, at least you practice with what you know, so you are good at it. How much time it took to create this? 5 minutes, right? Okay, if you know the function, you can do it. If you don't know the function, spend 5 minutes. Not much, but at least now you know to a new function which is doing the summation if the condition is true, or counting something the condition is true. Okay, so A must be a vector or a matrix, and then sum will check the condition and count. Okay, and the count is assigned to what? Pass. Okay, and in this case the count is assigned to full mark. Okay, and one more thing you can see here, display the statement, then next line display the value. So it will display like this, one line, second line, and same thing with the other. Okay, so but this is not wrong, but it just, to make more sense. Clear? Think which people like us do who don't know much, right? What we did. Okay, so write a MATLAB script which finds the percentage of positive numbers in a vector A. Okay, so out of the entire vector, how many are positive numbers? If you use the sum, now we are smarter, right? So we know sum. Okay, so how we can do it? Okay, so they are not counting 0, but 0 is a positive number. Okay, you can count 0 as positive. They are not counting it, but so if you get 0 in the exam, be positive. You got a positive number. Okay, I was watching a video and it was a funny video. So one of the students got -F. Okay. Another option is to do this. So you see another function now, right? Which is what? Mean. Now mean will do what? Okay. It will do the summation over length for this condition. Okay. Clear? So this thing which I wrote here, sum a greater than equal to 0 upon length of a, this whole thing will be done by mean. Yeah. So mean does what? It checks the condition and then calculates the percentage from total. Okay. Okay, and percentage of positive vectors using the if statement. Okay, so if statement, then you have to have a loop. The loop will run from 1 to the length of a, and each time we will check if the number is positive, I will count it, otherwise I will not count it. And then outside the loop, outside the if, I will do the total of count divided by the total length of a, okay, which is this one. Okay, so a, how much is length of a? N. So loop will run from 1 to n. Each time it will check the value of a. If it is positive, it will add in the count of post count. Okay, and then when you close the loop, it will take the post count divided by the total length, which is n, and give you the percentage. Clear? Easy, right? Any questions? Okay.